Hey everybody, this is Matt with MathsMath.com. Thanks for joining us here today as we check out special systems of linear equations. We're in the Common Core Standard of functions, and we're going to be defining, evaluating, and comparing different functions today, especially with linear equations in a system. Our guiding question is this: what kind of solutions are there to a system of equations? When we've looked at linear systems in the past, we've found that usually a system has one solution. Well, you know what? There can be quite a different variety of answers that you might get when you compare and look at systems of linear equations. So let's do that today, okay? So here it is. Here's some money. It's my favorite coin. It's my good luck charm. I bring this around with me wherever I go. And this is just a dollar bill. Well, if I make $1 a minute, think about it this way. This is a pretty cool scenario. If I make $1 a minute, do you care if you get paid in bills or coins? What do you think? Well, typically it doesn't matter, right? Is your rate any different? No, it's not. Just because the payment method might be different doesn't mean the rate is different, right? And so with linear equations, they might look different, but in all reality, those equations might be the same. Now, I'm not going to be wanting to walk around with $3,200 coins in my pocket, right? Much rather have dollar bills. Actually, $100 bills would be cool. But you know what? Looking at linear equations, they can be the same even though they look different. So let's do that, okay? This coin and this dollar bill look different, but they are worth the same amount of money. So let's talk about it. Well, this intersection, when you look at the intersection of the points, of the two lines, and you get that one point, what does it mean? What does that point mean? Let's look at the graph here. Okay, let's look at this graph and see what we find out. Well, let's look at the system here. Y equals 2x plus 3 and y equals negative x plus 6. Why don't you take a minute and graph that on your own? All right, did you get something like this? Should have got something that looks like this. Maybe not as fancy as mine, so they got the cool blue lines. But what does that mean? What does that point mean right there? Well, that's the solution, right? But at that point, the two equations actually equal each other. They're actually the same thing, right? At that point, they have the same point, same solution, and the two equations are equal to each other. So what could we do to solve it? Well, when they touch, they actually equal each other. Their answers are the same in x and y values. You plug them in, you plug the x and y values in, and you get the same answer, right? So what does it mean? Let's do that. Let's actually take them, put them equal to each other. And when we do that, they actually equal the same thing, right? That's where they meet. That's the y value where they meet. So 2x plus 3 equals negative x plus 6. That's where that intersection point is on the line, okay? Well, now what do? We just solve it and see what x equals. So here it goes. I'm going to take this, negative x, I want to bring the x over to the other side, and I want to bring this 3 over to the other side. Remember your steps in solving a linear system? So bring that x over, bring that 3 over, and you get x minus 3 on both sides. Add down, 2x plus x is 3x, 3 minus 3 is 0, negative x plus x is 0, and 6 minus 3 is 3. So now x equals 1. Okay, so at that point, x equals 1. But what does y equal? Well, all I got to do is take that x value, plug it back into the easiest and simplest equation, and it'll give me the y. So I take that 1, plug it in, negative 1 plus 6 gives me 5. So my answer is 1, 5. So at 1, 5, both equations actually equal each other. All right? That is called solving it algebraically. Well, when we solve it algebraically, we might find that there are different ways and different solutions that come up. Let's look at the different types of solutions that might come up here. Well, this one. How many solutions do we have here in this? In this system, how many solutions? Well, we've got one solution right there. Right smack dab in the point right there. One solution, 1 point. How many solutions do we have here? How many times do these lines intersect? Well, if you said none, you were right. There's no solution to this system of linear equations. They're two parallel lines. Notice they have the same slope. This one goes up and over. This one goes up and over. And they never touch. therefore there's no solution. Okay? And here's the hint with that. If the equations are in the same form, meaning they're both like the slope-intercept form or something, or they're both in the standard form, both on each side, well, if they have the same slope, and different y-intercepts, especially if it's in slope-intercept form, if they have the same slope and different y-intercepts, they will have no solution. That's the trick there, okay? So when you're looking at a system and they have the same slope and different y-intercepts, you know that they're parallel and they don't have any solution. That's the trick, okay? That's the easiest method to use. Now this one, how many solutions do these two lines have? Well, they are right on top of each other, aren't they? They have an infinite amount of solutions, no matter what. No matter what x point we have, they touch. Bam, 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 bam. Every x value equals a y value. The same on each. So, really, what are these? Well, really, these are the same line, aren't they? You stack them up on top of each other. It's kind of hard to show that, but they are stacked right up on top, and they equal each other. So again, with this one, if you compare the two, if you put them in both slope-intercept or in standard form, in slope-intercept form, they will have the same slope and the same y-intercepts. Duh, right? They're the same line. So, if they have the same slope, same y-intercept, they will have an infinite amount of solutions. That's the trick. So, notice, see any patterns here about both no solution and infinite amount of solutions? Well, they'll both have the same slope. So if you're putting them in standard form and you notice that they have the same slope, it's going to either be an infinite amount or no solution. Okay? That's the trick there. So whenever you're solving a system, they have the same slope, note that it's going to be something different. All right, so what about these ones? What are their solutions? This guy, y equals x and y minus 3x equals 2. How many solutions is it going to have? Well, notice if I move this minus 3x over to the other side, you've got x and 3x. My slope is different, so I'm going to have one solution. And that's what you can do just right off the bat. You can say, hey, you know what? They've got different slopes. There's one solution. So let's solve it, all right? Try solving it algebraically, setting them equal to each other. Remember, if you're going to set them equal to each other, you got to move this guy over, and so that they both equal y. So then it becomes x equals 3x plus 2, and you solve from there. Here we go. X equals 3x plus 2. Bring the 3x over, and you get negative 3x plus x is negative 2. So negative 2x plus or equals plus 2, positive 2. X equals negative 1. Plug negative 1 back in. This is the easiest one here. Like if you were to take the negative 1, put it here. What does negative 1 equal? Well, it's y. So x is negative 1, y is negative 1. There's 1 point. They both have this different slopes, so you know that there's 1 point. If you were to graph it, this is what you'd get. Put right there, negative 1, negative 1. Okay? All right, let's do this one. Remember, the best thing first to do is to make them equal to each other. So if you have y minus x and you have y equals, bring that x over to the other side. And what do you notice about the slopes here? They have the same slope, right? And do you remember that trick that I told you? If they have the same slope, and what about the y-intercepts? This is negative 2, that one's 1. So if they have the same slope and differing y-intercepts, you remember which one it is? Well, let's solve it and see what happens. All right? Again, we got to move this over, so move that minus x over to the other side, and you get x plus 1, which is the top one, and you got to set it equal to the other guy, and it's x minus 2. Okay? So you have x plus 1 equals x minus 2. They have the same slope, different y-intercepts. If you remember from the hint before, they're parallel, which means they'll have no solution, because what happens when if I bring this x over to the other side, it goes away, and you have 0 x's. Bring the 1 over to the other side, and you have negative 3. So then you have 0 equaling negative 3. Nah, can't do that. Totally impossible, right? Okay, so that's what happens there, is you bring that x over to the other side, bring the 1 over, and you get x equaling some random number, and that totally doesn't work. All right, so if you ever end up with something like this, it's a false statement, right? So these two statements can't be true here. This is false, so therefore there's no solutions whatsoever. Does that make sense? Remember, same slopes, different y-intercepts, no solution. All right, so you can probably guess what this one's going to be. Might not look like it though, huh? You got y equals negative x minus 2.5, and then this 2y plus 2x equals negative 5. So move everything away from the y, move the 2x over, get rid of the 2 there, and let's start solving it. See if you can do this one on your own. All right, how you doing? You able to get it to the y equals on both? Well, this is what it'll look like. Move the 2x over, you get negative 2x plus 5 divided by 2, and you get negative x plus 2.5 equals negative x plus 2.5. Well, same slope, same y-intercept, move the x's over, those cancel, and then you get 2.5 equals 2.5. Well, that's true. That's always true, right? So no matter what happens, it's always true. So these are the same exact line on top of each other. So it's an infinite amount of solutions. Just like I said earlier, same slope, same y-intercept, infinite amount of solutions, okay? All right, why don't you try these three guys? Find the solutions, solve them algebraically, set them equal to each other, see if there's any solutions. If you can use those hints, definitely do that. See if they have the same slope. If they don't have the same slope, then you know that there's actually one solution. But if they do have the same slope, then you know that something's up. There's either going to be an infinite amount of solutions or no solutions whatsoever. How's it coming? All right, well, definitely remember, move everything away from the y. You want y equals, put it in slope-intercept form. That's the easiest way to compare them. Move this guy over, move that guy over. Ready for the answers and the hints? Well, this is what you get. First one had an infinite amount of solution. Second one had one solution, and the third one had no solution whatsoever. All right. That's pretty much it, huh? Not too bad. Can you answer this question now? What kind of solutions there are to a system of equations? Bet you can. There's 3 for the most part for what we're seeing so far. And that's it for today. Thanks for joining us as we talked about special systems of linear equations and how to solve equations algebraically. This was Matt with mathsmath.com. Check us out on Facebook at Solving Maths Problems or on Twitter with Maths Math, and enjoy math.